Okay, so I figured I'd take a few minutes here and go over talk about the review from today. So this first number one and actually number six, I might just go over those back to back. These are the ones we have to come up with a piecewise function for the scenario. In this case, you're paying $20 for the month, and that covers your first 100 megabytes of data, which is not much data. But anyway, you pay $20, and that's a flat rate. Whether you use 0 or 2 or 10 or 100, you're going to pay $20. So that's the cost if you use anything less than 100 gigabytes, up to 100. As soon as you go over 100, though, like it says here, you get charged 15 cents per megabyte. So that's why the first piece of this is just a flat $20 for essentially 0 through 100 megabytes. But then for your second equation, now you got to incorporate this 15 cents. But you don't use it on the first 100, which is why we use x minus 100 here, because your first 100 are already covered. They're free. Well, not really free, but they're covered by the $20 cost. And then you add that additional $20 that you've already paid. Because if you think about it, if you used 101 megabytes, you pay the $20 plus 101 minus 100, which is 1 15-cent megabyte. So you create an equation that makes sense there. These parts are tough, but you have to just kind of, as you piece it together, you got to look at it and see if it fits what's going on in the scenario. And again, this would be used anytime your x is over 100, 101, 110, 200, whatever. Also, while we're at it, let's jump right down to 6, since it's the same style of question. The key to this one, you got to read it, and basically it says you pay $35 a day to rent the car, and then you pay $10 insurance. So overall, 35 and 10 means you're paying $45 per day, and that's for the first 3 days. So days 1, 2, and 3, you pay $45 a day. So for that first equation, that's why I said it's $45 per day for anywhere between 0 and 3 days. When you go to the fourth day, like it says here, if you keep it longer than 3 days, then the insurance fee drops down to just $5. So instead of paying $45 a day, since you're only paying a $5 insurance, it's now $40. So it's a little bit cheaper as you go to days 4, 5, 6, and so on. So now the rate changes to $40. But we've already paid for those first 3 days. So I take away the first 3 days and I add on what I spent for those first 3 days. So 3 days at $45 a day is $135. If you notice, this format for every one of these, if you look at the two examples in the notes, you look at this one, the one above it, they all follow that same format in terms of how you're coming up with these equations. We'll look at another one in the warm-up tomorrow too. All right, so if we kind of look at some of this other stuff, graphing a piecewise function, I would recommend the point method like we've talked about before, where you substitute these numbers in. I didn't do it for this one because this one I always think is just obvious. Like at -4, it's at 3, and at -2, it's at 3. So that's what I plotted here. Boom, little constant graph. For this, I took the -2 and I substituted it in, got -1. I took the 3 and I substituted it in, I got 4. So then I just plotted those 2 points and connected them because I know that that's a linear function. Again, both should be open because they're both open or both not included there. Same process here, but both points were closed because they are both included. Then it asks for all this information, the domain range, increasing, decreasing, constant, and so on. So the domain, this graph has, if you look at it, it goes from -4, continues through to 3, continues through to 5. So basically everything from -4 to 5 is in the domain, both values included. The range, I look at my graph because I can see very clearly here the lowest point, -1, the highest point, +4. So -1 to +4, but that one's open, that one's closed. So that's how I decide on my parentheses and brackets there. And then if you look at it, this graph is increasing only right here. So that's from -2 to 3. It's decreasing only right here. So that's from 3 to 5. And it's constant only right here. So from -4 to -2. And so that's where all those pieces come from there. Writing a rule is just the same thing in reverse. So you have a constant graph here at 6, and that's for any time your x is less than 0. This one, it's mx plus b. So I counted my slope was up 4, right 1. Y-intercept is at -6, so that's how I came up with my equation. I wrote it down, and then I just include its domain. This graph exists from 0 through 4. All right, and that's pretty good for this. I guess you got the step function here. Domain, same thing we talked about up there. All your numbers here, basically starting at 0 all the way through to 5, includes your domain. Again, pay attention to your signs. Your range, though, in this case, the only outputs, this is one of these step functions, you just get out 3, 5, 7, 9, and 11. You don't get anything else. So I wrote it in set notation. Nothing different, just listing the numbers that you can possibly get out, and that's it. On the backside, pretty much this whole thing boils down to, can you use your graphing calculator or your graphing app? So hopefully you watched that 1.5 video where I go over and talk about how to use the graphing app. I've been using the calculator a lot in class mainly because that's what we can use on the SAT. So I kind of like to prep with that. So if you have one, awesome. If not, you can use that Desmos app in order to do the same exact thing. So you want to make sure you've practiced that and that you understand how to do it. Nothing too crazy here. I think it'd be good to look at an inequality one. So number 4 would be a good one to look at, just to jump at something here. So if you look at number 4, I'm going to put in these in my y equals. So I go x squared plus 4x minus 5, and then that side's just 0. And then I graph it. And this question is asking me, when is this U-shaped graph less than 0? So when is it less than 0? Well, 0 would be the x-axis. So this graph is less than 0 here. So that's going to be from whatever that number is to whatever that number is. So it looks like it's -5 to 1. You can verify that in the table real easy. So I can see that at -5 I'm at 0, at 1 I'm at 0. If you're using the app, it just literally shows you the point right on there, so it's actually easier. But anyway, it'd be for everything between -5 and 1, and so that's what I wrote right here. Everything, all the x values that are greater than -5 but less than +1. These other ones where you use the intersect feature, again, if you're using the calculator, you're going to use the intersect feature. If you're using the app, it, again, literally just pops up. It's actually, I think, easier. But we just type it in, x squared plus 3x minus 5, and then 4x plus 3. So left side, right side, just go into 2 spots there. We graph them. We should see a U-shaped graph. We should see a line. And we do. If I'm using the calculator, I use the intersect feature. So second trace brings up my intersect feature. Pick up intersect. And first one's right about here. So I go enter, enter, enter. Boom, there's my coordinate. Wrote it down. Like I said, if you use the app, it's literally already on there. You just click on it and it shows you the coordinate. So those are actually simpler. So if you want to use that, you can. If you want to practice with this for like SAT and you have one, do that too. All right, and then same thing, head over here. You don't have to technically even have it on the screen. You just got to go near it. You press enter 3 times. And again, that's where I get my x value right there. So a lot of these on here are the same kind of thing. You just have to make sure you've practiced, that you can do them, that type of stuff. Number 13 we can talk about real quick. I solved 13 by writing equations, but you could do this a bunch of ways. There's not a set way you have to do 13. But you basically try. David starts with some money. He starts with $43. And he makes less per hour. Fatima starts with no money, but she makes more per hour. So like obviously she's going to catch up with his money eventually. So I wrote an equation for David. He had 43 and he's getting $8.75 per hour. And then I wrote an expression for Fatima. She just gets $10.25 an hour. And I'm looking for when does hers become greater? Or in other words, or when are they equal? Where's that break-even point happen? So I did it by graphing, and I used the table this time, but you could literally just solve this. You could subtract the 875 over and then divide both sides by whatever value that is, like Algebra 1 style. You could solve it by graphing and looking for the intersection. So I'll show you a couple options. You can do whatever you want. So I would just put those in here again. So what's 43 plus 875x, and Fatima's 1025x. So when I graph this, I believe they don't show up super awesome because they're going to intersect, but they're going to intersect somewhere way up here. So I was like, I could mess with my window, but instead I just went to my table. And here's kind of the breakdown is let me go here. At 0 hours worked, he has 43 and she has nothing. After 1 hour, he made some, she made some. So really we're looking for, when is this one going to overtake? Because obviously it starts off smaller. So I just went table route here and I just kind of scrolled down and I kept looking and I was waiting for when this one gets bigger, but it isn't yet. But she's getting close. And so very close. So right now she's 1 away. So obviously it's going to happen on the next one. And so that's why I said as soon as she hits 29, she's now made more money. So there's a table way of doing it. You could find the intersection the same way we've done it before. You could literally solve this equation for x just using algebra. Tons of ways of doing the same thing. That's really more of a review problem than anything. So hopefully that's pretty helpful. Obviously the whole key's on there as well, but I kind of just picked some key stuff to go over there.